about today is classifying the real number system. Okay? Now, many of you probably didn't know that there's numbers that are real and numbers that are not real. Okay? So in math, we have numbers that are called real numbers, and we also have numbers that are called imaginary numbers. We're not dealing with imaginary numbers. In 7th grade, we only work in the real number system. We only talk about real numbers, okay? So we need to understand what real numbers are, and then we need to know that underneath real numbers are all these other categories. Okay, so let's start with a real number. And you have this. Real numbers are considered any rational or irrational number. Any rational or irrational number. Okay, so fill in that blank. Okay, now all of the rest of these numbers that we're going to talk about are real numbers. Okay? Because under real numbers, there's two categories. There's rational numbers and there's irrational numbers. Okay? Close your Chromebooks right now. You don't need them. You don't need a calculator today. Put all of that aside. I just want you paying attention. This is super important that we understand these definitions. This is all about definitions today. We're not going to calculate anything. It's just definitions. Okay? So we have rational versus irrational. If they're irrational, they're over here by themselves. They can't be anything else. Okay? If they're rational, there's all of these under rational that they could possibly be. Okay, so we're going to start down here at the bottom. A natural or a counting number. Okay, a natural or a counting number, the definition is the number 1 and any other number obtained by adding 1 repeatedly. Okay, so when you were little, like little, like 3 years old, you started talking and you started learning how to count. What'd you do? What'd you do when you started learning how to count? Think of a 3-year-old learning how to count. What do they do? No, seriously, what do they do? What does a 3-year-old do? How do they count?
With their fingers.
With their fingers, right? And what do? They go like this. They go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then they run out of fingers and they're not sure what to do. But we know that you can keep going. Those are your counting numbers. Okay? Starting at 1 and adding 1 repeatedly. So put these examples in there. 1, 2, 3, 4, 5, 6, 7, and so on. It keeps going. Does it stop at 10 because we've run out of fingers? No, absolutely not. Okay? It keeps going. We go further than 10. We can go to 596. We can go to 1,797,852. Okay? But natural or counting numbers just keep going. It starts at 1 and it keeps going. Are there any fractions or decimals? When you're 3, do you use fractions and decimals? No. Okay. Then you get to elementary school and they tell you about another number. In kindergarten, or maybe before then, okay, preschool, maybe when you're like 4 and your parents tell you can have 0 cookies, right? And then you cry and you throw a fit, all of that, right? Those are considered whole numbers. Whole numbers are any of the natural numbers and 0. Okay? So when we're talking about whole numbers, it's all of these numbers. 1, 2, 3, 4, 5, 6, 7, and so on. But we also add 0 to it. So it's 0, 1, 2, 3, 4, 5, 6, 7, and so on. So the number 5, is that a natural number? Is the number 5 a natural number? Yes. We can count to 5. Is the number 5 a whole number? Yes. And notice how this is set up. Natural numbers are inside the circle of whole numbers, right? They're all included in there, but 0 is a whole number. Is 0 a natural number? No. When you learned how to count, you didn't start counting at 0. You started counting at 1. Okay? All right. Then we're going to move up to integers. What are integers? You guys should know this. We've talked about integers. We've done integers in 7th grade. What are integers? Integers are all whole numbers and their opposites. Well, not quite anything. It's all whole numbers and their opposites. So what would that mean? Give me some examples of integers, Elise. Yeah. It'd be like 5 and negative 5. 7 and negative 7. Is 2 an integer? Yeah. Is 0 an integer? Look at the definition. It says all whole numbers and their opposites. So is 0 an integer? Yeah. Is 15 an integer? Is 15 a natural number? Could you count to 15? Yeah. Is it a whole number? Yeah, it doesn't have a decimal or a fraction. Therefore, it's also an integer, because an integer is all whole numbers and their opposites, right? And notice, integers include all the whole numbers and all the natural numbers. They're all in that circle. Okay, then we get up to rational numbers. Rational number. We've talked about rational numbers. Rational number is any number that can be written as a, what? How do you think you'd fill in that blank? Fraction. Absolutely. Any number that can be written as a fraction. Including terminating or repeating decimals. Any number that can be written as a fraction, including terminating or repeating decimals. So give me an example of a rational number. Based on the definition, any number that can be written as a fraction. 0.25. 0.25. That's actually a terminating decimal, right? It's a decimal that stops. Okay, can you give me another example of a rational number? Any number that can be written as a fraction. Every single one of you should be able to think of one. Any number that's a fraction. Do you know a fraction? Are we alive today? Are you all breathing? Okay. Give me a fraction. 2/5. 2/5. That's a fraction. That's a rational number. Is 7 a fraction?
Yes.
Yes, because I could write it as 7 over 1, right? Okay. Repeating decimals. 0.3 repeating. That would be a rational number because it's repeating. Okay? 0.3 repeating is also 1/3. So that's a rational number. Is 1/3 an integer? No. Integers are whole numbers. So maybe you need to put a note on here. Integers. No fractions or decimals. There cannot be any fractions or decimals if it's an integer. Can whole numbers have fractions or decimals? Can there be fractions or decimals here? No. Again, whole numbers, no fractions or decimals. Can natural or counting numbers be fractions or decimals?
No.
No. Okay, so I'm going to try to trick you.
Okay.
Is 16 over 4 a rational number? It says any number that can be written as a fraction. Is that a fraction? Yeah, so it's a rational number. Can I put 16 over 4 as an integer?
No. Yes.
Yes.
What?
Why is 16 over 4 also an integer, Theo? Right? 16 over 4 is just 4. Right? 16 divided by 4. It's just 4. It can be simplified to 4. Okay? Is 16 over 4 a whole number? Yeah, it's just 4, right? Is 16 over 4 a natural number?
Wait. Yes.
Yeah, because it's just 4, right? So if you can simplify it to be those, then it can go there. Okay, how about the square root of 36? That's a rational number. Because the square root of 36 is 6. Can that go in any other categories? Or is it only rational? Can the square root of 36 go in any other categories? Where else could I put it? It could be 6, right? So therefore, is it an integer?
Yes.
So I could put the square root of 36 here. Is it a whole number? Is it a natural number? Yes. Okay. Can a number be only rational and not anything else? Yeah, right? We have some numbers. 1/3 is only rational. It doesn't fit in any of these categories. Okay? So some numbers are only rational numbers. They don't fit in anything else. If a number is a natural number, it fits in all of these categories. Okay? Now, we still haven't talked about this category over here. Irrational. Okay, a number cannot be both rational and irrational. Okay, just like you cannot be both rational and irrational at the same time. Think about that. If somebody is acting irrationally, what does that mean? It's kind of crazy, right? I act irrationally sometimes when my kids are really making me mad and I lose my cool. Okay? I know I'm acting irrationally. Okay, at that moment, I cannot act rational. Maybe an hour later I can. But at the moment, maybe we can't. Okay, so if you're irrational, you cannot be rational. Now, an irrational number is a number that cannot be written as a fraction. It's a number in which the decimal never ends and doesn't repeat. So can you think of any numbers that may be considered irrational? Think of any decimals that never end and never repeat. Pi. The number pi is an irrational number. Okay? That's the number pi. What's pi? 3.141596, blah, 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 blah. It keeps going.
2.
Okay, it doesn't end and it never repeats. Okay, I have a poster back here with the first 700 and something, 747 digits of pi.
That's a lot of numbers.
This poster has the first 777 digits of pi. So 3.14159265358973233846264338327950 and so on. Okay? Pi does not end. It keeps going. If a computer was going to start spitting out the numbers for pi, it would never stop. It would just keep going. Okay, Jackson.
Oh, I was watching a movie. I was watching Life of Pi this weekend, and they took all the chalkboards and filled them all up with digits of pi.
Yeah. People who memorize a lot of digits of pi, I don't get it. Like, I've known teachers that give extra credit for memorizing digits of pi.
What you do?
No!
Dang it!
That's a waste of brain space. You have so many better things you could use your brain space for. Okay?
Then I can win like
All you really need to know of pi is 3.14. That's all you really need to know. Okay? And other numbers that are irrational. There's lots of irrational numbers. Okay? The square root of 2 is irrational. Okay? If it's not a perfect square, then it's irrational. So the square root of 3, the square root of 5, the square root of 7, the square root of 8, the square root of not 9, right? The square root of 9 would go over here because that'd just be 3. Okay? So if a number is irrational, it cannot be rational. Okay. We kind of think we got a little bit of a hold on this. We're going to play a little game. It's called Name That Number. Okay?
It's 2, 7, 3.
I'm going to give you a sheet of paper.
4, 7. What are those on the same thing? I see it too. There's
Okay, grab one, pass it back. I'm going to show you a number. I want you to write that number in all the sets that you think it belongs. Okay? So we're going to go through it first. Don't write anything yet. Okay? These are all going to be real numbers, so you do not have to write them in the real number category. But when I show you the number, if you think it's rational, you're going to write it there. If you think it's an integer, you're going to write it there. I'm going to show you them all first, and then we'll go back through, and we'll make sure you have them right. Okay? Ready? I'll help you with the first one. 8. Okay, so I want you to write it in all the categories that you think it belongs. So I would put the number 8 under, I would start at the bottom. Can you count to 8? Okay, 1, 2, 3, 4, 5, 6, 7, 8, yes. So if it goes at the bottom, if it's a natural number, well then it's all of those. Okay, so 8 should go in all of those categories all the way up, but it's not irrational. Okay, because if it's rational, it cannot be irrational. Okay, so I'm going to let you do the next one, then we'll come back and we'll check them off. 16.3, where would you put that? Place that in all the categories you think it belongs. $16.3. Okay, next one. -11. Where would you put -11? Okay, the next one. 6.125486523 and so on 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 and so on. And it does not repeat and it does not end. 6.125486523. Okay, next one. 0.5 repeating. 0.5 repeating. Okay, the next one. -5/8. -5/8. 0.56. (9/3). (-121). Zero. One point two 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 two. So it's repeating. It's 1.2 repeating. 7/4. 7/4. Square root of 25. Pi. Okay, so now let's go back. Hang on a second. I want to make sure I have all of mine. So I'm going to tell you there should only be 2 numbers written in the irrational number section. If you have more than 2 numbers in irrational numbers, you have made some mistakes. You should have only 3 numbers in the natural numbers. If you don't have 3, you don't have enough. You should have 4 in the whole numbers. You should have 1, 2, 3, 4, 5, 6 in the integers. And you should have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 in the rational numbers. Okay, so now let's make some corrections. Okay, and let's explain what you did wrong. We already know 8. 8 goes in all of those. We can count to 8. Okay, every time I do these, my starting spot is down here. Okay, I always start at the bottom because if it's a natural number, it's all of these except irrational. That makes it really easy. Okay, so I'm going to go here, 16.3. Would you naturally count to 16.3? No, not at all. It's not a whole number, right? Whole numbers can't have decimals. Is it an integer? No, integers can't have decimals. So this one is only rational. So if you did not put 16.3 in the rational, put it there. Cross it off wherever else you had it. Maybe you don't have to erase, just cross it off. Okay? It's a terminating decimal. All right, negative 11. Would you naturally count to negative 11?
No.
When you were 3, did you count to negative 11? No. I don't care what kind of language you were speaking, whether you were speaking gibberish or baby talk or whatever. 1, 2, 3. You did not count to negative 11. Okay? So if it's not natural, is it a whole number? No, whole numbers can't have negatives. Whole numbers start at 0. Is it an integer? Yes. And if it's an integer, it's also rational. I could write that as a fraction, negative 11 over 1. Okay? So fix that if you needed to. The 6.125486523, and so on and so on and so on. That's a very long decimal that does not repeat. It does not end. It's irrational. When it's a crazy number like that, it's irrational. Okay. The next one, 0.5 repeating. If you put that under irrational, cross it off. Repeating decimals are rational numbers.
Oh, never mind.
Okay, repeating decimals are rational. I can't go down here. These are natural numbers. No, we didn't naturally count to 0.5 repeating. That'd be weird. Okay. Negative 5/8. When you were a baby, did you count to negative 5/8? No. It's not a whole number. Whole numbers can't be fractions. Is it an integer? No. Integers can't have fractions. It's a fraction, so it's rational. So negative 5/8 should only be under rational. Okay. 0.56. Where did you put that?
Oh, there it is.
Rational. It's a decimal that ends. It's a terminating decimal. Okay, it shouldn't be any place else. 9/3. What does 9/3 simplify to? 3. Can you naturally count to 3? Yes. So if we put it here, it is all of those. Okay, so 3 should have been in all of those or 9/3 should have been in all those categories. Negative 121. Integer and rational. It's a negative whole number, so it's an integer. It's also rational. 0. Do you naturally count to 0? No. Is 0 a whole number? Yes. So then it's everything the rest of the way up. Okay. 1.2 repeating. It's a repeating decimal, so it is rational. Rational only. Okay. 7/4. Where did you put that? Rational. I can't simplify that fraction. So therefore it's only rational. 7/4 is a fraction. We cannot put fractions over here. It can't be irrational. Okay? All right. Square root of 25. That just equals 5, right? The square root of 25 is 5. Can you naturally count to 5? Yes. So if I put it down here at natural, it's everything else above that. The square root of 25 is natural, whole, integer, and rational. Okay. And then pi is irrational. So that's our second number that goes under irrational. Okay, questions there? All right.